So students, moving ahead with another question of complex number. See, the previous one which we solved it with the help of geometry. This one we are going to solve with the help of algebra here. Okay, because see, looking at this complex number, mod of z minus 4 by z. So though we can still look at it, as we know that mod of z1 minus z2 represents distance between z1 and z2. We know that, isn't that? Distance between z1 and z2 on the argand plane, of course. But z is okay. But see, is that feasible to mark 4 by z with respect to z exactly on the argand plane? My answer is no. Okay, so in that case, so I will say, that's why I said I will be using algebra here. So what I am going to use? I am going to use modulus inequality. So the purpose of picking up this question was to discuss modulus inequalities, the type of question which you may find or where you may use this inequality here. Okay, so modulus inequality, what does it say? It says mod of z1 minus z2 is less than modulus of z1 plus modulus of z2 and on the other side greater than mod of z1 minus mod z2 whole within mod. Okay, so mod of z1 minus z2 or mod of z1 plus z2, both of them lie within the same two bounds, okay, for both of them. Now look at this. So I'll be starting with mod of z minus 4 by z. Let's apply. So this is less than equal to modulus of z plus 4 upon mod of z. We know that mod gets distributed over ratio of complex number and product of complex number. So instead of writing mod of 4 by z, I just wrote 4 over mod z. And similarly, this is greater than equal to difference of it. So mod of z minus 4 over mod of z, bachcho. Now this value is given. So this mod is given to be 2. So just put the value. So 2 is less than equal to mod z plus 4 by mod z. So this is one inequality, keep in mind, this is one inequality, and the other one is this is greater than equal to mod of z minus 4 by mod of z whole within mod, and this is our another inequality. So starting with our red inequality, this one. So of course taking, see, mod is always positive, so we have that liberty of multiplying the inequality by mod of z both the sides. So if I write it 2 less than equal to, taking LCM, plus 4 upon mod z, cross multiply, so we get mod z whole square minus 2 times mod z plus 4 is greater than equal to 0. Now isn't this left hand side and a quadratic expression in terms of modulus of z? Answer is yes. That's a quadratic expression. If I write its discriminant is b square minus 4ac, so which is less than 0. And since it's a open upward quadratic, why? Because the coefficient of modulus of z square is positive. Open upward quadratic with d less than 0. What does that mean? That means it's always above the x-axis. Okay, so if we treat it as x square minus 2x plus 4 and we have to solve for greater than equal to 0. So since d is negative, so no real root, open upward quadratic, coefficient of x square is positive, so it won't touch the x-axis, hence it is always positive. So that means this is nothing but an identity statement that doesn't give us any information here. Am I clear, bachcho? This is always true. Discriminant is negative, open upward quadratic, it's always true, it's always positive. So that's fine. So that means whatever we are going to get from here. So now writing is removing this mod. What will we write? Mod of z minus 4 by mod of z is less than equal to 2 and greater than equal to minus 2. I think all of you will agree to this. Okay, so if I write mod of t less than equal to p, so the solution is t lie between p and minus p here, bachcho. Okay, so now again let's these are two simultaneous inequalities. Okay, so and statement, so we'll be solving here them separately. So first solving this one. So this is mod of z minus 4 by mod of z is less than equal to 2. Okay, cross multiply, take LCM, mod z square minus 2 mod z minus 4 is less than equal to 0. Okay, now again open upward quadratic to be negative, it is negative between the roots. So it is always negative between the roots. So if I find the roots of mod z square minus 2 mod z minus 4 equal to 0. So the roots using Sridharacharya formula बच्चों. So what is it? So mod z is equal to minus b plus minus b square minus 4ac. So 14, 20, 2 root 5 by 2. So this is mod z is equal to 1 plus root 5 and mod z is equal to 1 minus root 5. So as I said, open upward quadratic will be negative only between the roots. Okay, so that means the solution of this inequality is between the roots. So mod z belongs to, of course, 1 minus root 5 is negative. Okay, so I will write 0 to 1 plus root 5. I think all of you bachon will agree to it. Okay, of course we won't be closing 0 because modulus of z, any complex number, is 0 only when that complex number is 0, and since we have a complex number as 1 by z in denominator, it can't be 0 anyways. So that's it. Now solving the other one means this one bachon, solving this one. So what is it? Just a minute. So it's mod of z minus 4 by mod of z is greater than equal to minus 2. So what do we get? Mod z whole square plus 2 times mod z minus 4 is greater than equal to 0. Now open upward quadratic is positive beyond the roots. Smaller than smaller root, larger than larger root. So what are the roots? Mod z is minus 2 plus minus, so plus 2 root 5 by 2 minus 2 minus 2 root 5 by 2. So larger than the larger root, right side of larger root. So either mod z is greater than root 5 minus 1 or mod z is less than minus root 5 minus 1. That's not possible. Okay, now as I said, these are AND condition. One is this, one is this. Taking their intersection. So how to take the intersection? So one says mod of z lie between this and what is it? 1 plus root 5. Okay. Another one says mod z is greater than greater than root 5 minus 1. So somewhere here, let's say root 5 minus 1. So let's mark them on the number line. So first condition is between here to here. Second condition is on the right side of it. So where do we have intersection? That's the common thing. So that means mod z belongs to root 5 minus 1 minimum value, root 5 plus 1 the maximum value, and that should be the answer. So the minimum is root 5 minus 1. Bachcho, maximum is root 5 plus 1. So that was the question directly based on algebraic inequality. Here I will say that I was not able to apply the geometry part, so I just focused on the algebra of like related to modulus inequalities here.